In this video, we'll try to detect internal defects in outdoor insulators using non-intrusive techniques. So the first thing we'll do now here in this experiment, we'll try to test two discs and both of them are healthy to show that there is no any partial discharge coming from this configuration. This is the PD detector at no voltage. As you can see, we have around 30 picocoulomb. So this is the background noise. Now we will energize these two discs at 30 kilovolt and we'll see that there is no PD coming. Now this is the PD detector at 30 kilovolt applied to these two discs of insulators, and as you can see here, still the PD level is around 30 picocoulomb, which is the same as the background noise. So at this voltage level, the two healthy insulators doesn't produce any type of partial discharge. Now we replaced the disc near the high voltage side by an unhealthy one. And this unhealthy discs were, its tan delta was measured and it shows very, very high value. Now we did this measurement in another video and I will leave the link of that video in the video description. Now let's come and see what is the PD level when we energize the insulator at 30 kilovolt. Now when we applied 30 kilovolt to these two discs, and one of them is defective, you can see here the level of the partial discharge is extremely high, 1.4, 1.5 nanocoulombs. The question is why we have such high level of partial discharge. Now we will be going to use different types of non-contact, non-intrusive sensors, and we will see these PD activities using these sensors. After that, I will explain what is happening and why we have this high level of partial discharge. Now, as you can see here, we can see at the tripling point on the top insulators, the one that is healthy actually, there is a lot of discharges at this tripling point. The question is why? This is what we're gonna explain as we move forward. We will use the ultrasonic sensor, and as you can see here, the laser beam are pointing at the tripling point of the healthy insulators. So let's see how much the activity of the ultrasonic sensor. So this is the PD activity. As you can see here, it's picking a high level of ultrasonic signals due to the discharge at the tripling points of the healthy insulator. This is the IR camera of both the healthy and unhealthy insulator. As you can see here, the bottom one, which is not healthy, shows higher temperature than the discs of the healthy one, which shows that there is some internal discharges inside the unhealthy insulators that led to the temperature increase. Let's explain what happened. When we have two healthy insulators and we applied 30 kilovolt, each disc of those insulators will share this voltage. So each one will have 15 and 15 kilovolt, and there was no PD activity at all. Now, when the bottom one was unhealthy, and there is some internal discharges inside, so the whole voltage, the whole 30 kilovolt will be applied now across the healthy insulators, and this will lead to some discharges as we have seen in the UV camera at the tripling point because of the very high stress here. And also the ultrasonic sensor also detected partial discharge from this region. Finally, the IR camera actually detected the discharge of the disc that has actually the discharge inside it. So this is basically three different non-intrusive ways that you can use to detect defects, internal defects of disc insulators.